Hi, this is Mr. Bo from MrBoEnglish.com. I've been talking to my students lately about word problems and how to look at word problems for quadratics. And I forgot to change my device here. Okay, so it would help if it were not white. Okay. Will that work? Okay. So if we if we have a quadratic equation and we have a parabola, I like to tell my students there are really only 4 or 5 things that a word problem will ask, but really there are 2 basic things that a word problem will ask. And one is, what is y when x is something, or what is x when y is something? And that doesn't help us much. So I'm gonna talk about the 4 or 5 things that are really common. And the first point that they'll ask about is this point right here, which is the start point, our initial point. And it'll always look like something, you know, like ask for this size here, and we'll ask a question like, how high was it when we started? And really what that means is, what is y when x equals 0? Okay? So that's question number 1. And question type number 2 will ask us about the axis of symmetry. And so it will often ask, when is the maximum? Or when is the minimum? When does it reach the high point? When does it reach the low point? And so what it's asking is, what is x when y is maximum or minimum? Another way to ask that is, what is the axis of symmetry? And my third kind of question wants to know this point here. Wants to know the vertex. So this one, if the vertex is at x1, y1, and we're using vertex form, then question number 2 asks us what x1 is, and question number 3 asks us what y1 is. And it asks, how high, or how low does it go? And it really wants to know, what is y on the axis of symmetry? Okay. My question type number 4 here is asking for zeros. So I may ask, when does it land? When does it land? When does it come down? When does it hit? When does it come up? When does it reach zero? When are we out of money? Lots of things. So when we want to know about when do we stop making profit, when in that case we're always asking for, the real question is, what is x when y equals 0? Or what are the zeros? Or what are the roots? So we have ways to answer all of these, and question number 1 is easy. If we have the formula, we just substitute 0 for x, and then we find y. If we want to know the maximum, we have a 4-step system to find that one. But we're going to find this will be a 3-step. So we'll find the zeros, and then we'll find the axis of symmetry in the middle there. Means that my other zero is probably going to be up over here. So between these two, there's a middle. And how high does it go? First, then we have to do all the stuff to find the axis of symmetry, and then we substitute for y, and we find y. To find the vertex, when does it land? It's just one step, and we find the larger x-intercept. So those are pretty much all the kinds of word questions you're going to have. So I'm going to look at a bunch of word questions, word problems now. A model rocket is launched from the ground and with an initial upward velocity of 475 feet per second. About how many seconds will it take to reach the ground? Reach the ground. That means, boom, this is a question 4. So it wants to know what is x when y equals 0. We're going to find the zeros for that. We're going to find the zeros. So one of the zeros is, on this one is 0, and then the other one, after we factor, we get negative 16t plus 175. That will look like negative 16t plus 175 times t. So 0 is 1, and then we'll solve for the other one this way. So that's one way to do it. I am going to look at my next one here. Okay, so I have a softball game. In a softball game, Lola hit the ball straight up with an initial upward velocity of 47 feet per second. The height of the ball in feet above the ground after t seconds can be modeled by the equation, this one. How long was the softball in the air before it hit the ground? Hit the ground. So again, what are we going to find? We're going to find this number 4. When does it land? So we're going to find the 2 zeros, and we're going to use the larger one. Use a little bigger here. Okay. The path of debris from fireworks when the wind is about 15 miles per hour can be modeled by the quadratic function h equals, where h is the height and x is the horizontal distance in feet. How far away from the launch site will the debris land? Where does it land? It's number 4. We're going to find the larger x-intercept. See what we're doing here? Okay, I've got farming here. I'll bring this up to the front. There we go. Okay. In order for Ray to decide how much fertilizer to apply to his corn crop this year, he reviews the records from previous years. He finds that crop yield Y, how much crop do you get? How much corn do you get? Or how much wheat do you get? depends on the amount of fertilizer. This is the amount of fertilizer he applies to his fields X according to this equation. Graph the function and find the point at which Ray gets the highest yield possible. So it wants to know how much fertilizer to use. Ray wants to know how much fertilizer should I use to get the most corn. So it wants to know, this is a question type number 2. When is the maximum? When do I get the maximum? So we're going to find the zeros, factor, find the 2 zeros, and then after we find the 2 zeros, we're going to average and find the axis of symmetry. Here we go. I've got a soccer example. If a goalie kicks a soccer ball with an upward velocity of 65 feet per second and his foot meets the ball 3 feet off the ground, the function represents the height of the ball y after t seconds. Approximately how long is the ball in the air? So this is going to be actually number 5 for us. They said I tell my students there are 4 or 5. So this is number 5, and it's oh, sorry, no, I'm wrong. This is actually a question number 4. The question number 4. So wants to know when it lands, how long is the ball in the air, when does it land, and so we're going to find the larger larger of the 2 zeros, of the 2 factors. So here we go. Here's another one. A hotel's main entrance is in the shape of a parabolic arch. The equation blah blah models the arch height y for any distance x from one side of the arch. Use a graph to determine its maximum height. So we want to know how high is it. How high is it? So we'll use number 3. We'll find the zeros. We will find the axis of symmetry, and from the axis of symmetry we'll find the height. Alright, I got a couple of more here and then we're going to stop. Okay, Mrs. Capwell's physics class investigates what happens when a ball is given an initial push, rolls up, and then back down an inclined plane. The class finds that y equals blah blah accurately predicts the ball's position y after rolling x seconds. On the graph of the equation, what would be the y value when x equals 4? So this is a very straightforward kind of question here. Sorry about that. Straightforward kind of question here, and we're asking what is y when x equals 4? So that really is just a substitution problem. So that's my fifth kind substitution problem. Okay, here we go. Architecture. A hotel's main entrance is in the shape of a parabol. We did that one already. We have 2 of those in here. Okay, this one's a big one, long one. Okay. Let me put this down at the bottom. There we go. The shape of the Gateway Arch in St. Louis, Missouri is a curve. It represents a parabola. It resembles a parabola with this equation where h is the height in feet and x is the distance. All right, so we have 3 questions. So they're going to be of different kinds. They're not going to be the same kind here. What is the equation of the axis of symmetry? This asked directly. So what is the equation of the axis of symmetry? That's number 3. So where is the middle? So how do we do that? We find the 2 zeros and we average. What is the distance from one end of the arch to the other? Here's a slightly different way to say this, but when does it come down? When does it finish? Okay. When does it land? How far away does it land? Okay, so that's still a question number 4. And what is the maximum height? What is the maximum height is a question number 3. Okay. So this one, A football is kicked from ground level at an initial velocity of 90 feet per second. The equation, blah blah, gives the height h of the football, and we've got 3 questions. What is the height of the ball after 1 second? And that's this kind of number 5 substitution. So we use t equals 1, and we find the height. No. When is the ball 126 feet high? And that's another. What is x when y equals this value? And when is the height of the ball 0 feet? That is the when does it come down? When does it land? And we find the zeros for it. All right, that pretty much covers all of the kinds of questions that you're going to hit for word problems. They pretty much all fall into here. Substitution is really easy because it doesn't take much. It'll tell you when time is at 4 seconds, how high is it, or what time does it hit 30 meters. So those aren't so difficult to identify, but these other 4, it's good to know that there's really only these 4 things that 4 points that they want to look for. All right, so if you have any further questions, go ahead and hit us up on MrBoEnglish.com. Thank you. Mr. Bo English รับสอนนักเรียนตั้งแต่ป .3 ขึ้นไปทางอินเทอร์เน็ตในสไตล์ EP ครับ ผู้สนใจช่วยติดต่อครูแจงหรือไปเว็บไซต์ที่ www.mrboenglish.com